Those of you who are familiar with or longtime DFO members and maybe even regular meeting attendees are familiar with our speaker tonight, Dave Leatherman, since Dave is a regular speaker for DFO. Dave's a native of Columbus, Ohio. He has a bachelor's degree in biology from Marietta College and a master's degree in forestry from Duke. He retired after more than 3 decades of service as forest entomologist for the Colorado State Forest Service. And he has a special interest in the food habits of birds. Dave's active in the Colorado Field Ornithologists, where he writes a column called The Hungry Bird for the Colorado Field Ornithologist journal, Colorado Birds. He has seen 460 species of birds in Colorado, including being part of 4 first state record bird sightings, the latest of which is the Couch's hummingbird in Lamar in 2015. Welcome, Dave.
Thank you. That was a kingbird. Couch's kingbird.
Couch's kingbird. What did I say?
Hummingbird, I think.
Oh, I did. Oh, Couch's kingbird. Of
That's
course.
okay.
Thank
I'd
you.
love to see a Couch's hummingbird too, but
yeah.
Anyway.
To be discovered.
Okay, let's see. I got to get this right here. Okay, so welcome everybody. I'm glad to be back sort of in front of the DFO, and I'd much rather be at the museum or at the church seeing you all in person, but this will work. As Bill said, I worked for the Colorado State Forest Service. I was hired back in the mid-70s when there was a major pine beetle epidemic in the state. Legislature decided to fund a position in the Colorado State Forest Service for an entomologist, and I jumped into the fray of the pine beetle and realized early on that as a person who was apparently well suited to be a public servant, my heart was in the field with our district personnel. That's who I felt the strongest need to assist, or that seemed to fit my job better than working in the state office or running down to the legislature. And so I was in the field with our field foresters as much as possible, with landowners and with the resource. And I can honestly say that over all those years of being in the field, I became very fond of ponderosa pine and ponderosa pine forests and the habitat that grew that tree. And I've long thought this tree needs to be celebrated, and this might be a love the one you're with kind of thing, but I'm sure there's people all over the world that think the tree that grows in their piece of forest or in their river bottom is the best tree in the world, and it probably is to them. But to me, we are lucky along the Front Range to have this tree next door and occupying a major part of our forest habitat. So I'm going to call it the best tree. So Albert Bierstadt, if you're familiar with him, has several wonderful paintings that sort of show the West back in the Romantic days when there weren't very many people and there were wide open spaces, and we were thinking about concepts like national parks. And this is his depiction of Yosemite and Bridal Veil Falls up there in the background. And a lot of those trees in the foreground, I am sure, are ponderosa pines and maybe some sugar pines mixed in there. But that's the image that a lot of people have of this tree and where it grows, and it's not quite that romantic here in Colorado, but there's places, especially down in southwest Colorado and the southwest part of the state, where it can look pretty similar to that. Other names for this tree are bull pine, western yellow pine, rock pine. Young pine trees have dark bark and are called blackjacks by foresters. And this tree has a lot of other names in local areas, but we have the subspecies Pinus ponderosi scopulorum, and in the southwestern part of the state is the southwestern subspecies Brachyptera. This tree, one of the great things about it is that if you get up close to the trunk and you're a tree hugger, it smells like vanilla, which comes from some of the resinous compounds in that bark, made up mostly of terpenes. And I don't have a sense of smell anymore because I think those jars we used to collect insects and kill them that were laced with carbon tetrachloride in the early days, and then cyanide, sodium cyanide, I think that wiped out my sense of smell, or maybe it's just the dry conditions out here in my sinuses. But anyway, I wish I could smell that vanilla bark again. And this tree can be over 100 feet tall in Colorado, and there's one that is pushing 300 feet in California near Yosemite. The oldest one we think is west of Colorado Springs, around 800 years old, and the oldest one ever recorded, it wasn't alive, but from tree rings, it was measured at over almost 1,050 years old at Mesa Verde. Other characteristics of this tree are that the needles are usually 3 to a bundle. In our urban areas, for some reason, a lot of the urban foresters have chosen Austrian pine as a pine to replace ponderosa pine in our urban landscapes. And I'm not sure why we didn't plant a native tree, but Austrian pine is commonly planted in the cities, including Denver area and all along the Front Range. It's a darker green tree, and usually its needles are in bundles of 2. Sometimes ponderosa can be in 2s, but if you count 10 bundles and you get a 3, 3, 3, 3, 2, 2, 3, 3, 2, the majority of which are 3s, you're probably looking at ponderosa pine. The reason this tree can resist fire is because it develops very thick bark, especially in the lower trunk. And that is an evolved characteristic that counts on frequent low intensity fires that don't go very high up the trunk. And those trees resist they don't die from the fire, and the fire cleans up the undergrowth and the fuels, and we have these nice open grown stands like you see in those Bierstadt paintings. The terminal bud is usually dark reddish brown, as opposed to Austrian, which can be pretty white. The cone scales, if you grab a pine cone and don't do it carefully, you're going to get poked by these prickles at the end of each cone scale, and we'll show a picture of those later. But the little sharp thing on the end of Austrian pine is not nearly as ominous as the one on ponderosa pine. Old trees have a yellowish bark, and that's why some of those common names had the word yellow in them. And you can see these really cool puzzle patterns sometimes if you get really close to an old tree and look at the ground. Some of the shed scales of the bark look just like somebody threw a puzzle on the ground. And then the bark has little tiny dimples in it that are filled with resin, and I mention that because sometimes back when people are looking at pine beetle and they're looking for holes in the bark, they mistake those dimples for something made by an insect. I'll show those. So here's the bark of ponderosa pine on the left, or the bud, terminal bud, and you can see, other than that whitish resin that's kind of dried on there, if we scraped off that whitish frost, the color of that bud would be pretty dark, reddish brown, mahogany colored. And then the Austrian pine on the right, you can see is much paler, excuse me. So here's these bundles I was talking about, and that little dark area at the bottom where the needles come together is called a fascicle, or the bundle. And so if you're looking at a pine tree and trying to identify it as a ponderosa pine, I would look at those bundles, cut one of those out of the herd and see if it's 3 needles to the bundle. And if it is, it's ponderosa. If it's 2, it could be some other things. And here's this bark I'm talking about on an old mature tree, maybe from 10 feet away, the trunk of a very large tree, 30 to 40 inches in diameter at chest height, looks like that middle picture with those big plates. Looking at one plate there on the left up close, you can kind of see the puzzle pieces, and then I pulled some of those off, or pick some off the ground and just set them out so you could really see them. And they do look quite a bit like a jigsaw puzzle. So here's one of those resin flakes, and you can see those little dimples, and each one of those, when it's fresh, is filled with this vanilla flavored or vanilla smelling resin. And it would be neat to fill a whole jar with that stuff and then put it on your mantle and stir it up once in a while, and it would really make your house smell nice. So here's the range of ponderosa pine, and this particular map that I found online, the blue at the dark blue at the bottom is actually now thought to be a different species, Pinus arizonica. It used to be considered a subspecies of ponderosa. So you can see us up there in the turquoise, and then you can see how the Brachyptera, the southwestern ponderosa subspecies, kind of inches up into that southwest corner. So around Pagosa Springs, Durango, that's where you can see this tree that almost looks like a different tree than the ponderosa we see on the Front Range. It's got just a much more majestic shape, and they are taller, and it's a magnificent tree, especially down there. But I've seen some pretty fantastic trees up north too, up at Red Feather Lakes and other places. And then there are 2 subspecies out in the west of us, the coastal species in green, and then one up in the interior Pacific Northwest up into BC is the one named for Bentham, the botanist Bentham, Benthamiana. So the elevational range of ponderosa pine roughly is 5,000 to 9,000 feet is where it naturally occurs. So the majority of what we call the montane ecosystem is where ponderosa dominates. It is the dominant tree, especially on south-facing slopes, and kind of leaks around to the east and west side of our mountains, mid-elevation mountains. And then, of course, Douglas fir dominates on the north side of those mountains, and often mixes in with ponderosa pine. With climate change, we're seeing that change a little bit, and ponderosa pine is coming all the way around the mountain as the north side kind of dries out with warmer temperatures. But in general, you got spruce and fir and lodgepole up above ponderosa pine, then you've got ponderosa pine and Doug fir. Then down low, you've got the grasslands and maybe some pinyon juniper forests. So this is a typical ponderosa stand along the Front Range. I took this up in Rocky Mountain National Park, and it shows you that, you know, with fire and without any active intervention on the part of humans, this tree naturally grows kind of open grown in what foresters call an uneven aged condition, as opposed to a tree like lodgepole pine, which gets its start in a forest fire that melts the cones and throws all the seeds on the ground all at once. Lodgepole pine grows up even aged, and every tree looks almost identical, and in fact is probably in most local, you know, areas within sight of one tree, every tree around it is the same age exactly to the day of that tree. But ponderosa pine stands are like this, uneven aged, and when something comes along, usually it doesn't take out all the trees at once, because most causal agents only like one type of tree or one age of tree or one stress level of tree. So these trees, this was taken down near Dolores, and these would be the typical southwestern subspecies of ponderosa pine, the Brachyptera trees. And usually the understory is gamble oak, and it just looks very different down there, ponderosa pine. But Pinus is Latin for pine tree. The ponderosi is derived from the word ponderous, because the wood is heavy. And then scopulorum, our subspecies here along the Front Range, means of the rocks. And if you ever see a ponderosa pine get blown over and you can see its root system exposed, you can see how the root system is just all intertwined with decomposing granite, and literally it is of the rocks. Its name in Spanish is Pino Real, the royal pine, and Lewis and Clark, William Clark on the Lewis and Clark expedition is the first white man to notice this tree back in 1805, and he took some samples, but they got lost in the shuffle. And actually, David Douglas, a botanist, is the one who formally described the tree near Spokane, and he's the one that gave it the common name of ponderosa for its ponderous or heavy lumber. All kinds of interesting ethnobotany with this tree, and I just selected some of the things that I could find online. But the seeds, if you take the wing off the seed and just eat the kernel or the nutlet, many tribes of native peoples ate those. The inner bark was peeled off, so the inner bark or the phloem layer, I always compare, the analogy I use is an Oreo cookie with, you've got one dark cookie is the bark, then you've got the other dark cookie is the wood, and the good stuff in the middle, the white stuff, is the phloem, and that's the layer that the tree stores all of its sugars in, which are the products of photosynthesis done by the needles, by the leaves. And so the phloem is where it is, where the action is in terms of nutrition for humans and for many animals. And some of the Indians, Native Americans that peeled the bark, you can still see the evidence of that, and I'll show you a picture later. But they peeled that phloem layer off, which is not very thick, you know, maybe a ½ inch thick on a very big tree. They dried it, and then they made that into flour. The trunk was used for dugout canoes. They used that pitch for all kinds of things, waterproof their moccasins, fix leaks in their canoes, even used it on the inside of their flutes to give it a special tone, and had various medicinal uses. My favorite one is the shoe swaps made a needle mixture that was a deodorant. And here's a little shoe swap child, very happy that her men folks in her camp use ponderosa pine deodorant, and she's happy about that. And she has a feathered headdress that had me wondering what those are. And I'll leave that up to you guys to see if you can figure that out. But I'm guessing it's some kind of hawk. And here's one of these scars I was mentioning that you can still see where they carefully pulled a huge section of bark off the tree while it was alive, scraped that inner bark layer off, dried it, and made it into flour. And this is down west of Durango, over toward Hesperus. And the area is called the Target Tree Recreation Area on the San Juan National Forest. And I think there's still some of these trees still alive where you could see this. I used to know some women that lived in Buckhorn Canyon west of Fort Collins. They were wonderful characters, Helen and Alice Dickerson, and they used to weave baskets out of ponderosa pine needles, and they sold them as tourists, and they had a little stand by the dirt road where they would sell Cokes and their baskets. And one of them, I forget which one, I think it was Helen, wove the baskets, and then Alice painted a bird on the bottom, and she picked an appropriate bird for a ponderosa pine basket, the Steller's jay. And I can honestly say two of my proudest possessions are two baskets made by these women who are no longer with us, but they are buried in Grandview Cemetery, where I bird quite frequently, and I feel comforted when I walk by their headstone. It has hummingbirds on it, and remember their voices. They were really cool ladies. Okay, so yes, some of the native peoples even ate insects that were feeding on ponderosa pine, one of which is this creature, the Pandora moth. And they different tribes used this insect different ways. One of them, the Modoc and Klamath Indians in Northern California, made the caterpillars into a stew, which was called bullquanch. And I read an account by a cavalry person who befriended these native peoples, and they treated him with a meal of bullquanch, and he didn't like it. And maybe bullquanch tells you everything you need to know about that dish. I'm sure it's an acquired taste. Something that probably I think we would like better without having to learn to like it would be the roasted pupae. And these caterpillars drop to the soil after they're done feeding and pupate in the leaf, in the needle litter and upper inch of soil, and they would dig those out and roast those, and those were probably a lot better, I'm guessing. So this tree takes 2 years for the cones to mature. Those pinkish cone-like things at the bottom are the male cones that produce the pollen, and that's a close-up of a pollen grain, a couple of them in that right picture down below. They only produce a good cone crop every 2 to 5 years. So if you're a bird that really relies on those cone crops, you can see why some of those birds like crossbills and nuthatches and jays have evolved a very nomadic lifestyle, and we see them one year and not the next, and they have good years and bad years, just like their food, the seeds in those cones. And ponderosa pine is what we call a monoecious species of tree, and that is, it means one house. Monoecious means one house. So both male and female flowers are in the same house on the same tree. And there are dioecious trees where we have all the male flowers on one tree and all the female flowers on another tree. Green ash is a good example of a dioecious tree, but pines are monoecious, and there's some pollination going on. The flowers of the same tree are pollinating the opposite sex flower on that same tree, but there's a lot of wind-blown pollen coming in from nearby trees, so it's not totally a dead-end street DNA-wise. So this is that prickle at the end of the cone scales that I was talking about that makes, you have to pick up a pine cone, a ponderosa pine cone carefully because of those things. They will stick you, and that is called an umbo. And you can remember that word for your next Scrabble game. But those are evolved to provide some protection from birds and squirrels, especially when the cone is closed. But when it opens up like that one, like both of these are, it's a little easier for these animals that eat the seeds to get them out between the scales. This is one of 41 species of pines we have native in the United States. If you plant one in your yard and you want some pine cones, you're not going to get one until it's at least 16 to 20 years old. A lot of people are allergic to the pollen and maybe don't even know that's what it is. But if you have some kind of an allergic reaction in late May, early June, it could be, and you live in the foothills, it might be pine pollen, because that's when they flower. Right now is when these cones are opening up or ripening, the seeds are ripe, and the cones are beginning to open up, and there's a lot of action in terms of seeds falling out of these cones. And I've had great fun in the last week watching the bird response to these seeds becoming available. Those other facts there are pretty much for nursery people, you know, how many seeds per pound, and some of those things they care about that in the nursery because that's their business. So when the new growth begins in the spring, that light colored terminal growth is called a shoot or a candle. And then you can begin to see the needles protruding from the tip of that candle. So the stalk forms first, and then the needles elongate from that candle. I wanted to show this because at this time of year, you can see a lot of ponderosa pines that look like this, where the terminal growth is nice and green, and then there's these puffs of brown on each branch, and those are the older needles. So a typical pine tree or evergreen conifer has several years of needles on it at one time, but not all the needles it's ever had its whole life. So this tree that's maybe 50 years old has 5 years worth of needles on it. That means it lost 45 years worth of needles. And conifers, evergreens lose leaves in the fall, just like a deciduous tree. They just don't lose them all. And the ones they do lose are the oldest ones. So you know your tree is okay if this is what it looks like. If it's the reverse and the terminal growth is turning brown, then you maybe have an issue like pine beetle or something else. But I wanted to show this because a lot of landowners used to call me and worry that their trees looked like this. It meant they were dying of pine beetle, and that's not the case. They're just natural needle drop. In bad years, drought years, they lose more needles than good years where we had good rain, but they lose some every year. So ponderosa pine and fire is a marriage made in heaven, and ponderosa pine forests are supposed to burn probably lightly every 10 years would be a typical fire cycle for this part of the world. Because we've put houses where we probably shouldn't put houses, we've had to put fires out, and that's part of the problem we're seeing right now with when we do have a fire. It's a horrific fire, and it's because we haven't allowed the light cleansing type fires that would be natural to burn. Plus, we've got the complications that are added in by climate change, but part of it's our own doing with the invention of a certain bear character that I'll talk about later. But typical, these crown fires, like in the picture, those are not what normally happens. Normally, the fire runs along the ground and it's burning needles and drop branches and other woody plants, and the dominant overstory trees are not killed by those light frequent fires because of that thick bark. These are pictures I took the other day of a tree that had burned in the High Park fire west of Fort Collins, and this is burned heartwood. So this tree had exploded, like half of it blew off one side of the tree, and you can actually see the hollow interior of the tree and the burned wood, and it was actually quite beautiful if you just ignored the fact that that tree got burned up. But the bark itself, the burned bark, had a lot of beautiful colors on it, and it was just part of a natural cycle. It could be you put houses in there and everything changes. One very interesting thing about ponderosa pine is that it plays host to another plant, a parasitic plant called dwarf mistletoe. And we have a handful of different species of dwarf mistletoes in Colorado that affect pines and Douglas fir. And then we have one that's not a dwarf mistletoe, it's a leafy mistletoe that we see on junipers. But this plant is pretty darn amazing, and it starts out as a sticky seed that flies through the air. The plant shoots its seeds explosively under water pressure, and a tall tree that has an infection up high, the seeds have been measured going as far as 60 feet out from the top of that tree, and they land sometimes on the ground and nothing happens. Sometimes they land on another tree. They slide down a needle under the influence of rainfall, and they sink a root system into the new host and grow this. This is full-grown mistletoe. It has no leaves. It looks like coral, and in fact, I saw a golf course down by Durango that had a nature trail, and one of their interpretive signs interpreted coral fungus, and it was actually talking about mistletoe that was on the tree, and I didn't have the heart to tell them they need to change their sign, but it does look like coral. So here's a picture that was taken in a lab of the seed exploding through the air, and foresters, students at forestry camp, it occurs at the time of year when these seeds are ready to go, and you can learn how to trigger them with your finger, and you can shoot them on your buddy up in front of you, or stick them on the girl's hair that you want to talk to. And dwarf mistletoe has been the kind of the cloud seeding of many relationships among foresters. But on the right there, you see a female mistletoe shoot, and the seeds are about ready to fire off. And they actually, when they are ready to go, they elevate to an angle that gives them a maximum projection. And foresters long wondered, how do these infections get started in the middle of the forest? You know, normally mistletoe starts from one infected tree, and with the seeds shooting out, it creeps through the woods, goes to the next tree over, the next tree over, and it moves through the forest at a snail's pace. And then every once in a while, you'll find a mistletoe out in the middle of totally uninfected trees. How did it get there? Well, a friend of mine, Frank Coxworth, who's now deceased, and his technicians figured it out, and they figured out that those three animals there at the bottom mess around in a pine tree, and they brush up against a shoot of mistletoe when it's ready to go, and the seed fires off and sticks on their feathers or their fur, and then they fly somewhere and they preen and they knock the seed off, and they're the source of these long range infections. Certain animals do feed on dwarf mistletoe, including the caterpillar of this butterfly, the thicket hair streak. It's very camouflaged and hard to see. It looks just like a section of mistletoe trunk. And at the arrow, you see a full-grown thicket hair streak caterpillar. And they don't really do anything in terms of controlling mistletoe. And they're just an interesting part of the whole situation. This is a great man here, Frank Coxworth, and he died early in my career, and I really enjoyed his mentorship early on as a young forester, and I'd hang out and just listen to him talk. But he's written everything there is to know about dwarf mistletoe, and almost all the U.S. Forest Service publications he wrote. And one of the coolest things about this guy, he used to have a map in his house, and it was a map of the United States, and he had pins with those little pins with the colored heads on them, and he had put a pin every place he had been looking for mistletoe, and the whole map was full of pins. But he was a very funny guy, and his sons are still active in natural resource professions. Frank Coxworth. This disease, Western gall rust, is one you might see. Probably you won't see it like this, where it makes a little swelling on a branch and there's some orange spores being produced. That only happens like 1 week a year. But what you might see are trees like these two with these big gnarly areas on the trunk, or cankers. And they're called hip cankers when they're on the trunk, and some of them are massive. But that obviously, if you were growing ponderosa pine for economic purposes, that would not be what you want in the part of the tree that is the most valuable in terms of lumber. So that, in operations where trees are being grown for lumber production, gall rust is something that you work to eliminate. Mycorrhizae are fungi that are doing amazing things down there in the soil, and they are fungi that bind with the roots of various plants, including ponderosa pine, and they aid in the uptake of nutrients from the soil. They're almost like fingers for those roots, and they're just a relationship that improves the ability of the pine to get the most out of where it's growing through its root system. And these fires that we've been having, these very hot, unnatural, hotter than they should be kind of fires that burns the soil and, turns the soil to glass and melts the silica in the soil, and it doesn't come back as trees like it should. A lot of that is the fact that these hot fires, these crown fires, these fires that are burning in areas that have excessive buildups of fuel due to the lack of frequent fires, it kills the mycorrhizae, and that's a big part of the reason why these forests don't come back quickly, and maybe we should be doing a whole lot more manual tree planting to kind of help the reforestation process. Everybody's probably seen these structures, like on the left there, these horse hoof or shelf fungi, and those are the fruiting bodies of species of fungi that are decaying the wood. And this is the one on the left is called red belt, and it's very common. And decay is part of the process, and trees live and trees die, and decay is one of the things that breaks them down quickly. And I've had a lot of fun in the last several years going up to a site in Risk Canyon and seeing all the things that live and contribute to the breakdown of trees that have died in fire or of pine beetles. And it's a marvelous process to watch all these other organisms, and decay is one of them. You know, when the wood boring beetles put a hole in a dead tree after something kills it, like say fire or lightning kills the tree, and then the wood borers come in secondarily and start putting holes in the wood, and then the water goes in the holes and makes it moist, and then decay fungi can grow and start breaking it down, and then carpenter ants are going to work on it. And it's just a fantastic process that we get pretty impatient to watch, and we just want instant trees. We don't want it to change. We don't want anything to die, and we've got to get more tolerant. Everybody's probably seen these beetles and wonder, what is that pretty blue beetle I see with the black polka dots? And it is a pleasing fungus beetle, and that beetle, the larvae of which is at the bottom there, feeds on the spore producing surface of those decay fruiting bodies, or conchs as they're called. And it's just part of the process. So when you see one of those blue beetles land on you or fly past, you know somewhere nearby is a dead tree that has a decay fungus on it, and that beetle made its living off of the fungus. So this is the bottom surface of a spore producing fruiting body of a decay fungus, and those little tubes produce the spores. And mushrooms have their spore producing surface arranged like gills, or like pages of a book. And then these polypore fungi have this arrangement. One of the things you see commonly in an old pine forest where there's tall trees, especially ones that are sticking up at the top of a ridge, and they're the highest thing up there, is lightning strikes, and these big stripes that go right down the bark, and it's pretty skinny at the top, and then it gets wide toward the bottom. It would be a magnificent thing to see if you could see it at a distance, to watch one of those. But that is a common way when things like the pine beetle are at low levels. The pine beetle that is out there, the smattering of pine beetles that survive between epidemics, are in trees like this, in trees that died of a lightning strike, or maybe there was a landslide, or gully washer washed soil off the roots, and that tree starts to die, and then the pine beetle lives in those stress trees, or special acute episode trees like lightning. Abert squirrel is declining, and I think it's because ponderosa pine is declining, and ponderosa pine is declining because we're putting a lot of houses in places where ponderosa pine is. The lower mountains are easier to colonize by humans than the upper mountains. The weather's better and the terrain's flatter, and so Abert squirrel needs old pine trees with pine cones. It eats other parts of the tree It eats the needles, it eats the bark, but it needs old trees that have cones, and it needs a lot of them. So this squirrel is an indicator, I think, of ponderosa pine health. And when we have lots of them, we've got lots of old pine trees. Porcupines also feed on ponderosa pine, and they're doing the same thing those native peoples were doing, trying to get to that phloem layer, the inner bark. And in my experience, they find a tree they like, they keep going to it, and eventually they chew enough bark off the branches, getting that phloem that the tree, usually it doesn't die, but a lot of the branches do die, and it has a pretty sorry looking crown after multiple years of porcupine favoritism. And I mentioned down there, do they have a relationship with Boy Scouts? And that's because I got asked to go to a Boy Scout camp up in Boulder County. And the guy took me to an outhouse and opened the door, and the seats on the toilet were all chewed. And he asked me if I knew what was going on. And it was porcupines coming for the salt. The male species is not always the best aimer, and the squirrel or the porcupine was feeding on the salt on those wooden outhouse seats. And they had the same issue around their amphitheater, where the kids would just during break would go out into the woods and pee on the trees, and the lower trunk of those trees had urine on it, and the porcupines were chewing those up too. So there's a relationship, not as solid a relationship at the Girl Scout camp. We have a tree nursery in Western Fort Collins, and we grow lots of ponderosa pine seedlings for sale for conservation plantings. And after they've grown for a year or two in the greenhouse, they put them outside for a year under a kind of a shade house that is open around the edges. And it snows most winters, and sometimes when the snow melts, they find out that they've had a problem with voles living under the snow, and those voles are girdling the bottom of those seedlings. And that's an example of what that little vole does when it's feeding in the comfort of protection of snow under, and the tree still looks green up above, and then it eventually dies, but we can't sell those kind of trees. So it's quite common. And here's an animal that has influenced the pine forest probably the most, and that's Smokey the bear. He's a human invention, and he was started for a good reason, but I think he got too successful, and we've come to depend on putting out fires when really we should not be putting houses in some areas and letting fire do what it's going to do naturally. But we've modified the mountains more than just homes, and we've got water conducting pipes going from this reservoir over to the Front Range, and power lines, and there's a lot of reasons why we can't just let fire do its thing. But I think the main reason why Smokey Bear maybe could be somewhat of a villain in terms of this, why some of these fires are so bad is, or why some of the pine beetle infestations are so bad, is because we've put out too many fires and saved all the trees for pine beetles. And or when there is a fire, it's a horrendous fire. So this is a butterfly that feeds on ponderosa needles, and sometimes you can see that butterfly at puddles up in the mountain roads. There's another butterfly that eats ponderosa pine, the pine butterfly. And I did see an epidemic of that insect out in the Black Forest east of Monument, down toward the Air Force Academy east of there. And, they chewed up the trees pretty good, but it looks like a cabbage white butterfly, but it's just a relative. And you see lots of little white butterflies up in a pine tree. It's probably this one, the pine butterfly. If you can see those needles on the right, there is a larva inside the needle, and it's a needle miner. It's mining inside the needle, and it does the damage that lots of needle miners cause a pine bough to look like that on the left. And that usually doesn't kill the tree, but it's just an interesting thing that you sometimes see. If the base of the needles are green and the outer tip is brown, it could be salt, it could be drought, it could be needle miner. So you hold it up, and if you see a critter inside the pale area of the needle, then it's the insect. These are pine sawflies that also feed on pines, especially out in the Black Forest. And they are named for that saw-like ovipositor that you can see in that picture on the right. And then that is used to saw a little slit in a needle, and then an egg is deposited in each slit. So that's a female sawfly, adult sawfly in the upper right. And she's laying eggs in that pine needle with her saw-like ovipositor, pine sawfly. And so that is a wasp that is a defoliator. And then there's other insects that chew on the needles. Sometimes when you're driving in the mountains in the winter, you see a big white, looks like a tent caterpillar tent in a pine tree, and that's this pine tiger moth on the right. And they're all loaded up with antifreeze, and they're in the caterpillar stage in the dead of winter. So the only way they could do that is to have some special chemistry. And they feed in there inside that tent, which insulates them somewhat from the weather. And then they've got that chemistry. On the left is a pine tussock moth, which it is, I saw up in Nebraska, actually. But you've probably seen these insects in your house. That's the conifer seed bug. And they have those back legs with that big wide leaf-like structure on the hind leg. And that's why they're called leaf-footed bugs. But that picture on the left shows them clustered all over a house up in conifer. And they do come inside houses in the winter. And so they're a nuisance when they do that, but they don't really cause any problems. They just come in your house and cause you to have to charge the battery on the shop vac. Lots of little insects feeding on the pine needles, aphids, spittlebugs, scales, and this black and orange cicada is the one that clicks. And if you go in a pine forest in late spring, early summer, and you hear a clicking sound, it's a cicada, and most cicadas make a shrill buzz, but this particular one makes a click, and it occurs in pine forests. And this cool looking insect is a snake fly, and it is a predator on anything it can find. Quite common in ponderosa pine forests. So when I say I got hired because of the pine beetle, and so I'm going to talk a little bit about the pine beetle, but the historical role of bark beetles in forest systems that's the way fire and bark beetles are the two ways that conifer forests die in the West commonly. And if it's not fire, it's beetles. If it's not beetle, it's fire. And they create dead trees and all those organisms that live on those dead trees. And then a new forest grows back, and there are these big cycles. And humans don't like those cycles because they want to live in the pine forest and want it to be the way it was when they bought it. But these cycles, the other problem with these cycles is that they're so long. I think humans that have a 90-year, if you're lucky, life cycle, some of the beetles alternate on 300-year cycles in the spruce forest, and I think we have a hard time relating to these. We think the end is coming when really it's just a natural cycle, and we're not very patient or not willing to put up with it. But the mountain pine beetle is the one that affects ponderosa pine, and it I think in the old ecological concept of keystone species, it's definitely one. It's a species around which a whole bunch of other species revolves. It's the #1 killer of western pines, and that's what they look like in that picture. This is what they can do. I took that picture from a Cessna 172 in Boulder County back in the 70s, and if your house is in the middle of that, you're not very happy. And they can kill a lot of trees in a short period of time. Usually an epidemic is maybe 10 years long, and it seems like it's going to kill them all. It doesn't, but it will kill a lot of the bigger trees, that's for sure. The way you detect it is usually three things: boring dust, which just looks like sawdust. It's just chewed up bark as they enter the tree or as they exit the tree. They produce this stuff and it accumulates around the base of the tree. So if you have a pine tree and you see a ring of powder all the way around it that's the color of ground up fresh bark, probably that tree is dead. So boring dust is one of the three things you look for. These so-called pitch tubes, which develop at the attack point where a male-female pair of beetles entered a live tree that's somewhat hydrated enough to put out an attempt to push it out with resin. These little popcorn-like resin masses form at the attack points, and if there's enough of those, the tree loses, the beetle wins. If there's not enough of those, sometimes an attack is repelled by the tree, and it's a war going on between the defense system of the tree and the beetles' strength in numbers. But I put my money on the beetles when the tree's the right age and stressed enough. They've got some amazing chemistry that allows them to attack, concentrate themselves, aggregate, mate, and attack, lay lots of eggs, and then they actually have another pheromone that they put out that when they've got enough to overcome the tree, they put out an anti-aggregating pheromone that makes it so the party doesn't get overrun with too many beetles and they outcompete each other. They get just the right number to overcome the tree, and then they cut off the attack and do their thing. Besides pitch tubes and boring dust, then you can actually detect trees by looking for woodpecker activity. And this is an example of where hairy woodpecker has removed patches of bark trying to get down to the beetles, which it wants to eat. So the hairy woodpecker is a major predator, and three-toed woodpecker is a predator of the spruce beetle higher up. But to really confirm an attack, you got to look under the bark using a hatchet. And I don't know how many times I was chopping on a tree and looked up and there was a hairy woodpecker up above me doing the same exact thing. We just had different tools. He wanted my hatchet, and I was kind of thinking his beak looked like a cool thing. But so I have a fond spot for hairy woodpeckers. They were my buddies out in the forest. Here's the gallery pattern that if we took a square of bark off the tree and turned it over, that's what it would look like. That's the phloem layer, and the big tunnel running down vertically through the middle is one made by the parent beetle. Then the little galleries coming off to the side were made by the offspring, and you can see the larvae, the pupae, and then even some parasites in that system. And you can see the blue stain, the fungus that they bring into the tree that also helps them with the rapid killing of the tree. Here are the larvae, look like little grains of cooked rice. And there's all kinds of relationships with this beetle and other organisms, and they have different types. Like all of these are all symbiotic relationship. So symbiosis is the overarching term for any kind of an association of two, long-term association of two organisms. It can be commensalistic, where only one of them benefits. It can be mutualistic, where both of them benefit. And it can be parasitic, where one of them really suffers from that relationship. One of them benefits, one of them really suffers. The mutual or the commensalism is one benefits, the other one's kind of unaffected. The parasitic is one benefits and one is harmed. So the relationships of the pine beetle that we see involve fungi and mites that are called phoretic mites. That means hitchhiking mites. They cling onto the beetle and actually fly with it to a new tree. That's their benefit, is they get transportation, but they also help the beetle when they're under the bark with it, or they might be parasitic. Some of them eat eggs, bark beetle eggs. So there's different relationships of mites. There's yeast, bacteria, nematodes. Very complicated, and I don't think we've got it figured out yet. They're getting better, but so far, look at those numbers: 13 different mites, 13 nematodes, 3 kinds of blue stain fungi and yeast. And there's a lot of stuff going on when a pine beetle kills a tree, and that paragraph at the bottom explains one theory about how they think it works, but the blue stain fungi clogs up the water pipes in the tree, almost like an embolism. The fungus just plugs the pipes, and then the feeding on the phloem prevents the main repair material, which are sugars. They are feeding on the sugar, so there's not as much material available to repair the embolisms. That's one of the theories. So this is a head of a cross section through a beetle, half of a beetle, the head end of a beetle, and the head is at the top, and there B is the brain. So just below the brain is the eye, and that there are these little invaginations of the body wall called mycangia that carry this fungus, nurture these blue stain fungi that the beetle carries. And it's an evolved relationship to where the anatomy of the beetle is modified to carry this fungus around, and the beetle doesn't actively place the blue stain in the tree. It just, in the process of it boring in, and the way those pouches are situated, some of the spores of the fungus spill out, rub out, and it's introduced into the tree. So it's a pretty amazing relationship. Management of pine beetle is usually 2 categories: prevention of the beetle in the first place, with kind of reducing the number of trees in the forest so that the ones that are left are vigorous. Sometimes we can prevent attack on a very valuable tree by putting a chemical on the trunk so that when the beetle comes, it can't get through the layer of poison. Sometimes we try to clean up. We cut down the infested trees and try to remove them from the site, or otherwise kill the beetles so that the population doesn't fly to new trees. So there's 2 camps, and they're hard to do and not without controversy. But there's a thinning. That's what a forest looks like after a thinning, designed to prevent bark beetles. And it's not ugly once the slash decays, and it's about every other tree is removed, and it still is a pretty forest, but yet it's much more resistant to the beetle. And here's an example of what happens when we thin a forest. This tree was growing very slow because of competition from other trees. We remove some of the competition, and the rings get wider. The tree's growing better, and it's more able to repel attacks. To a point that it's not a absolute, but it is helpful to have a faster growing tree. But here's an example of a house that maybe there's a few trees in there that they really want to keep around their house, and they might preventively spray those trees just to artificially keep them there. And there are plenty of other bark beetles in pine trees besides pine beetle, but the pine beetle is the main one that we know about that kills the most trees. But I say succession is a beautiful thing. You go from a green tree to a bark beetle tree to secondary wood borers to woodpeckers to the fungi to the tree falling down, the ants have a party, and then new seedlings, and back around the cycle we go. It's a beautiful thing when we can allow it to happen. And I think there's too many people injected into the situation, either in terms of homes or recreation, that we can't always let this happen, but it would be neat if we could. So I say the tree on the left is more alive. I'd have a lot more fun in that dead tree because of all those secondary organisms. And these are the main biological controls of pine beetle in our area: hairy woodpecker, and then these flies and certain clarid beetles. After the pine beetle kills the tree, then these secondary insects come in, which I refer to as lawyers. And they're actually accident, but they didn't do it. And here's the famous lawyers I could find: Frank and Johnny and Perry Mason, for you guys that are over 60. Just to remember that when you see that beetle, it's secondary to whatever the problem was that killed the tree. Pine beetle lightning, somebody carving on it, septic system, who knows what, something killed the tree, and then that thing comes in, the longhorn wood borer, the white spotted pine sawyer, very common insect, long antennae. And this is the biggest beetle in the state, the ponderous borer, not ponderosa, but ponderous. It's a very large beetle, and it's in that longhorn wood borer family also. And they're pretty awesome insects. When you see one, they make a huge hole. Here is a larva in my hand that I pulled out of a ponderosa log down by Dolores that was on the ground. It was the consistency of angel food cake, and I was just grabbing handfuls and pulling it apart just to see what was in there. And here was this big thing, and it lived for 5 years in my kitchen in a Tupperware container with some of that angel food cake that I pulled in, that I found it in. And it never would, I was hoping it would go on through to adulthood and I would get to see the adult, but it just stayed in that larval stage. I took it to homeowner meetings and took it to the state fair and showed it to people. And I had a little Hispanic girl in Pueblo stole it from me. She liked it so much, and her grandma made her bring it back 3 hours later. And Grubby was quite a hit with a lot of people, but that's a big larva, and I have big hands, so you can see how big that thing was. But that's a larva of a ponderous borer that would make a pretty good hole in a piece of wood. And there's other borers in wood. And the last few years up in Risk Canyon, I've got down on my hands and knees and looked at these logs, and there's amazing little cool things going in and out of holes. And these are just some of the wasps and bees that I've seen in those downed ponderosa logs that were killed by fire or pine beetle. And they'll have a different lifestyle and purpose, but marvelous little creatures that we would pay money to see if they were just bigger. But especially that one in the upper right, I mean, that is a cool little wasp. When the wood gets really decayed after the pine beetle and the lawyers have had their way with it, then the ants continue the breakdown process, and they can make these elaborate Anasazi ruins in the wood. And they're just excavating the wood. They're not eating the wood like termites do. That's just a home they carved out of that rotten log, and then they go out and feed on other things. So they're not like termites. They just excavate. So when you see carpenter ants in your log house, or that doesn't mean the house is going to fall down. It may mean you need to control a colony if that's at a weight-bearing point in the structure of the house, that might not be good, and you may have to just control a little area, but that's not the same as the feeling you ought to get when you see termites. This is a big beetle with these big eye spots, and it feeds in those rotten logs. It's called an eye delator. It's a type of click beetle. And then these tiny little scorpion looking things, pseudo scorpions, I find them all the time under the bark of these dead trees. Very cool little creatures. Don't have a stinger, not a problem to anything. This is a book I'll mention if you're interested in having a reference book of all these kind of things. This is a book you can get from a cooperative extension, so probably the closest one to most of you is in Jeffco, at the Jeffco Fairgrounds, but you could get this book, and it has a zillion pictures of insects and diseases of our woody trees, including the ponderosa pine. Extension Bulletin 506A is what you want to ask for, and it'll cost you $50, but it's worth it. We do have a few reptiles that live in the ponderosa pine, like the shorthorn lizard. I see these commonly down in the southwest part of the state in those big trees, not so much up in the Front Range ponderosa. And then the milk snake is sometimes seen in the ponderosa pine forest under logs, under rocks. Beautiful thing that looks a lot like a coral snake, but it's got the different, I don't know if you can see the little ditty at the top, but there's a way to remember how it's not a coral snake. We don't have coral snakes in Colorado anyway. And there are some rattlesnakes in ponderosa pine. So what about birds? You guys are DFO, Denver Field Ornithologists, and I get carried away with the other stuff. I'm sorry, but there are a lot of cool birds in ponderosa pine, and all those chipping sparrows that we see migrating through, they're headed for the montane zone, and a lot of them are living in the ponderosa pine forest. And we've got about 100 species of birds that nest in ponderosa pine or migrate through it or winter in it. And a lot of them are, I would consider them indicator species of, if you saw them, there's probably ponderosa pine around, including the western tanager, which ought to be our state bird, I think. But that mostly nest on the branches and then feed on insects and sometimes fruit. Down in the southern part of the state, and actually ponderosa pine goes way out on the plains, way down in Los Animas County. And you can find hepatic tanagers down there in the pine. It's more of a typical of the Southwest, but the Southwest creeps up into Colorado in Los Animas County. And I've seen a few hepatic tanagers down there, and especially on those Nature Conservancy properties that only Ted Floyd can go to. Band-tailed pigeon is another bird that is often in ponderosa pine up in Estes Park, and I don't understand this bird because it seems like where I see him, it doesn't look that special a habitat, but you only see him, seems like very locally, and I don't quite understand what it is that band-tailed pigeons need. But ponderosa pine is often part of their habitat. And I think it's cool they were discovered in Colorado near Sedalia during the long expedition. Grace's warbler, where do you think of, when you think of Grace's warbler, you think of Durango or Pagosa Springs, but I think we're starting to see more and more of them on the Front Range, and probably they were somewhat overlooked, but I think they're also increasing. And down in Beulah and Rye, in that Pueblo city park that's in Beulah, and they've been seen in Boulder County. I think Christian Nunes has found nests of Grace's warbler in Boulder County. There are probably a few of them all along the Front Range, and maybe it's going further north with climate change, and we might even start seeing them west of Fort Collins one of these days. Dusky grouse is often in Doug fir. It eats a lot of Doug fir needles, and Doug fir is usually intermixed with ponderosa pine. So I'm calling this a ponderosa pine bird, even though Doug fir is probably the critical component of the woody plant habitat. But here's a picture of one attacking my grandson's foot up there by Lookout Mountain, and probably some of you guys saw this bird, and unfortunately it got killed by a truck, I understand, but Trey was not so sure that this bird wasn't going to hurt him, and I had to pretty forcefully ask him to just put up with the gentle pecking. And a lot of broad-tailed hummingbirds in ponderosa pine, a lot of nests in the lower branches of ponderosa pine. In Fort Collins, the ones that I see urban Fort Collins, they're always in blue spruce usually, but sometimes in other trees. But in the foothills where they are, quote, supposed to be, a lot of the nests are in ponderosa pine. And here's a nest of one in Grandview Cemetery in Fort Collins, where the bird built its nest out of spider webs and other fluff, dandelion seeds and cottonwood fluff, and then decorated the outside of it to kind of blend in with the tree it was in with, in this case, bud caps. So those bud caps pop off the terminal buds, and then the needles elongate. And this one used those bud caps to decorate the whole outside of its nest. And I've never seen that before or since. Whoops. Olive-sided flycatcher is a distinctively ponderosa pine, maybe lodgepole, a little higher up sometimes, but that's a ponderosa pine bird in large measure, and they don't seem to be as common as they used to be. I don't know, but they eat a lot of yellow jackets. I know that. And Cordilleran flycatcher is another ponderosa pine flycatcher. Often nests on cabins and gives that distinctive squeak it call in the ponderosa pine forest. And I hear way more of them than I see, but that's that's the input of ponderosa pine. Whoops. Lots of little owls in ponderosa pine. These three, the flammulated northern pygmy and saw-whet, sometimes all can be in ponderosa forests. Saw-whet's typically a little higher up most of the time, but pygmy owls and flammulated owls are often in that 5,000 to 9,000 foot range with ponderosa pine and Doug fir. Oops, here's a pygmy owl in a ponderosa pine forest up Poudre Canyon and Gateway Natural Area. Very hard to see when they're in a tree like that, even if you know that is a tree they frequent. It's really tough to see them unless they're teed up in the top of the tree. Of course, the Steller's jay is the poster child for birds in ponderosa pine. And none of us should misspell that word, stellar, ER, named for a person. Won't be named that for long, but as long as it is, we ought to spell the guy's name right. George Wilhelm Steller. It's a stellar bird, but name for stellar. Here's a pinyon jay that sometimes eats ponderosa pine seeds when it can't find limber pine, when it can't find pinyon pine. And I think these pinyon jays that we see this time of year kind of roaming all over are just looking for a resource that they can rely on over the winter. And they go out on the eastern plains, they come down to the 4,000 or 5,000 feet. And when they do, a lot of times it's the time of year when ponderosa pine is dropping its seeds, and they eat a lot of them. Of course, Clark's nutcracker is tied mostly to the white pines, the 5-needle pines, the bristlecone, limber, white bark pine in Nevada and in the Great Basin, but they do eat a lot of ponderosa seeds. And here's one pulling seeds out of a cone up on the backside of Horsetooth Mountain. And on the lower right picture, you can see the guller pouch that they have. They pack zillions of seeds in that pouch and then, cache them in the ground. And Dr. Tomback in Boulder has done unbelievably cool work figuring that all out, and how many they cache and how many they forget, and how important they are to reforesting fire areas. And that Frank Hawksworth that I mentioned earlier, Dr. Hawksworth told me that you can find pinyon pines up in the canyons west of Fort Collins. And we have Owl Canyon Pinyon Grove up north of town, which nobody knows for sure how it got there, but it might have been Native Americans that planted them. But Clark's nutcrackers take pinyon nuts from that grove and fly up into the foothills and bury them in the middle of ponderosa pine forest and Doug fir forest. And every once in a while, you'll see a pinyon pine up west of Fort Collins growing, and it's a Clark nutcracker planted tree from the pinyon grove up north of town. So these birds are amazing, and ponderosa pine's part of the deal, not central to their existence, but maybe it will be if the white pines get wiped out by white pine blister rust and pine beetle moving higher on the mountain because of climate change. Pygmy nuthatch is another one that's strongly tied to ponderosa pine. And I was watching these the other day, getting seeds out of cones. And there's one on the lower left there that's got he cut the wing off the seed, and he's got the kernel ready to cache it stash it in a bark crack or whatever. And this is, what are we going to call the Cassin's finch? Maybe the dipped in raspberry juice pointy beaked finch, if we want to be real descriptive. I don't know about the name changes. I'm all for getting rid of some of those names of the dudes that were clearly bad, but I don't know. It's going to be hard for somebody my age to remember all these new names. It's a plot between the book people and the taxonomists, I think. But this one, so what kind of tree is that sitting in? I think I heard somebody out there say ponderosa pine. You see that 3-needle thing there? Here's the evening grosbeak up at Lake Estes the other day, pulling seeds out of ponderosa. Of course, the red crossbill, type 2, eats lots of ponderosa seeds. And that amazing bill is good at opening up those scales and pulling them out. And one of my favorite birds, the red crossbill, and type 2s are probably the most common one we see along the Front Range. Here's mountain chickadee just the other day, getting seeds out of a fallen cone. And then the hairy woodpecker, I mentioned its role is it's in ponderosa pine because of the bark beetles and the wood borers that are in those trees. And it is a major predator of those. And it would, if you were a little pine beetle larva, just minding your business in the dark under the bark and the beak of a hairy woodpecker came through your roof ceiling, that would be a bad day. Here's two examples of hairy woodpecker. On the left is an example of where a hairy woodpecker has removed 20 or so wood borer larvae, 20 of those lawyer larvae from under the bark, and those holes are the size of a nickel, so they're way bigger than any insect would make probably. On the right is a place in the bark where it started to remove probably a bark beetle, a smaller thing, and those little slits are claw marks in the bark. Acorn woodpecker, this is the one down by Rafter J west of Durango that's caching gamble oak acorns in the bark of a ponderosa pine killed by pine beetle. So acorn woodpecker is sometimes associated with ponderosa pine mostly as a home, a place to excavate a hole to nest in, and as a place to store their granary, to place their granary to store their acorns. This was probably a bird of the ponderosa pine forest in Colorado formerly, the thick-billed parrot. And these are all birds that maybe we'll see in the future in ponderosa pine if climate change continues to bring birds up. Greater peewee, painted redstart, red-faced warbler, buff-breasted flycatcher, pine flycatcher, flame-colored tanager, magnificent hummingbird, and orange-billed nightingale thrush. Wouldn't that be cool to see those birds? But not the reason why we would see them is not so cool. So I better stop this thing and just state that I think these pine forests are wonderful and that we're lucky to have lots of natural areas and lots of access in terms of national forest land, public land near us. And we ought to go out there and try to find birds and not just chase birds and see what's going on with all this stuff that revolves around that beautiful tree. So thank you for your attention.
Thank you, Dave. Thank you very much. I think we all have a better appreciation of what an ecosystem a ponderosa pine forest is, from mycorrhizae to beetles and squirrels and birds and all kinds of things. So how complex it is, and you've been great in explaining much of that. Thank you very much.
Okay, well, thank you.
We have some questions. One question is, and maybe your final statement there addresses this, but why, in your opinion, is the ponderosa pine the best tree?
Well, I mean, it has many economic uses. You know, it was one of the major lumber trees of the West. And then I think because of how widespread it is, covering a large portion of the Western United States, especially the accessible altitudes to us humans, the lower mountains, and that wonderful biodiversity. It's beautiful to look at. It smells good. And I'm probably biased because I spent a lot of probably person years wandering around in ponderosa pine trees. But I would entertain arguments from other people about other trees and probably not fight them to the death. Okay. If they said something else was better.
Okay. In the decay beetles that are involved in ponderosas, are they also common to other trees like spruce and fir?
Yeah, a lot of the bark beetles, a lot of them are specific to pine, but the wood borers, the lawyers are a little less individualized, and they may occur in several conifer trees. You know, you might find that longhorn wood borer, the spotted sawyer, in spruce, Doug fir, and pine, maybe even true fir. But the bark beetles, the little primary insects that kill them are pretty specific to one one group of trees and maybe even one species of pine tree. But the farther down the successional scale you go, the less specific they are. So those ants are going to be excavating many kinds of trees, and the wood borers, some trees, and the little bark beetles, one or two trees, kinds of trees.
Okay. Is there evidence to suggest that the birds and squirrels like Aberts that are prevalent in ponderosa pines are adapting to other pines as the ponderosas decline?
Well, I guess I might have given the wrong impression. Ponderosa pine is probably the most sustainable of all the pines, just because it occurs over such a huge area, over 5,000 feet elevational range. It's not at the top of the mountain like spruce or ptarmigan that doesn't have anywhere else to go when it warms up. I mean, ponderosa pine will probably be around. I think some of the other pines like pinyon might be more susceptible to climate change than ponderosa pine is. The thing that it's going to be the conflict in the future is this climate change and fire. And I think there's going to be a big movement that, because of people, and people come first to politicians, that we're going to have to put out every fire, and we're going to have to rake up every pine needle that's looks like fuel. And I think there's a danger of going too far with that kind of stuff. And we're going to have to decide, where do we let things go and be natural, and where do we groom the forest? But I think all we have to do is look at Europe to see that maybe grooming the forest to a fine degree is not the way to go for all of it, certainly. And I think we've got to learn how to do control burns and accept the occasional one that gets away. You're dealing with a wild animal, and even Siegfried and Roy that have the tigers at Vegas, they got bit or scratched once. I mean, we're dealing with a wildfire. With something like fire, you can have all the parameters you want to be right weather-wise when we start these things, but the weather changes around here fast, and occasionally one of those fires is going to get away. And I think control burns are a great thing. And every time one gets away and somebody's house burns up, that sets back the willingness of the public to accept that as a tool. And either we're going to have to let more fires burn, to practice more prescribed burns, or we're going to have to cut some trees. And I used to go to these homeowner meetings, and I say, a log truck, fire, or pine beetles, pick one. You have to pick one if you live in a pine area. And they say, we don't want any of those. Well, that is not fair. If you don't want fire to burn up your mansion, I understand that. But if you don't want that to happen, then you're going to have to probably do some arranging of the trees around your house to not be a setup for failure, or you're going to have to let the pine beetle do it for you. And it's not fair to call me when the pine beetle comes and you've eliminated fire and you don't want chainsaws. I can tell you one of the three is going to happen. I can't tell you what year it's going to happen, but I can tell you it's going to happen. So, land managers and landowners have got a tough thing with as many people as we've got on the Front Range, and it's going to get worse. There's going to be more and more. We've got some tough decisions to make about management of fire, and especially pine trees, and what's supposed to happen in a pine forest for it to be healthy is frequent light fires, and we just can't have that or accept that nowadays. And so what do we do in lieu of that? It's tough, tough decision.
Okay. Does dwarf mistletoe kill the tree?
It can. Normally it doesn't. It lives, it's a parasite that it wouldn't be in its best interest to kill its host. So it coexists with this tree. It gnarls it up. It pulls resources from it and steals nutrients and water and other things that would go to the growth of the tree for itself. But it normally doesn't kill the tree, and usually only in combination with other factors like drought or something else weather-wise does it kill the tree. But it can surely, if your idea is to grow a pine forest for lumber, you don't want mistletoe. If your idea is to have, if you don't care about having kind of a misshapen, gnarly forest, then it's going to be a lot more interesting than a forest without mistletoe. I'll put it that way. And this Mexican spotted owl nests in mistletoe areas where mistletoe has caused the branches to proliferate, what we call brooms, witches brooms, the dense branching areas. That's where the spotted owl puts its nest, the Mexican spotted owl. So Mexican spotted owl and mistletoe go together. So mistletoe is often considered a foe of commercial forestry, but as far as interesting forestry, it's okay.
Okay. Are ingested mistletoe seeds still viable after excretion?
No, because they wouldn't. Well, I don't know. That's an interesting question. I don't think that they wouldn't have the viscum that allows them to adhere to a pine trunk or a branch long enough for it to sprout. So it may be viable, but it doesn't have a way of sticking to the substrate that it needs to grow into an infection. But I don't think I've ever seen anything where they, if they took one of those seeds that went through a bird and glued it to a tree, could it cause an infection? That's a good question. But I don't think it'll ever happen because it can't stick to the part of the tree it needs to sprout.